Way back in Aristotle's day, Aristotle believed that the speed at which things fall is proportional to their mass, right? So essentially, Aristotle believed that heavier things fall faster than lighter things. I've written this up on the board. Well, today we know that this isn't true. We know that things fall at the same rate regardless of their mass, right? Many of us are familiar with Galileo's famous experiment where he went to the top of the Leaning Tower of Pisa. He took two balls, a heavy ball and a lighter ball, and he dropped them off at the same time. And the balls both hit the ground at the same time. And he proved, right, that things fall at the same rate regardless of their mass. However, most historians actually think that this experiment never actually took place. So how did Galileo prove, right, that things fall at the same rate regardless of their mass? Well, we do know that Galileo had a book called On Motion, and in it, he provides a thought experiment. And the thought experiment actually proves that things fall at the same rate regardless of their mass. And I would like to share with you that thought experiment today because I think it is really quite interesting. So let's actually make an assumption for this thought experiment. Let's assume that Aristotle was correct. Let's assume that heavier things fall faster than lighter things. Why not? Let's imagine a universe where that's true. Okay, so we'll erase Aristotle and we'll put that this is an assumption that we are making. Well, how do we prove that this isn't true? We're going to provide a contradiction. We're going to provide that this assumption is contradictory. And we'll do that with this thought experiment. Okay, so let's say that you have two objects, a light object and a heavy object, right? So we'll write that on the board. We have a light object and we have a heavy object. Two boxes. We'll say the light object is this one and that it's 1 kilogram. We'll say this is the heavy object over here. We can say that this is 2 kilograms. All right. Well, let's attach these two objects with a string. Very fun. And let's take this, these two objects attached by the string. Let's take it to the top of a very tall tower. Let's say the Leaning Tower of Pisa, why not? And let's drop these two objects off the Leaning Tower of Pisa. What do you think will happen? Well, we know that the 1 kilogram object will fall slower than the 2 kilogram object. I've denoted it by these arrows. The longer arrow means that it falls with a greater speed than the 1 kilogram object. And of course, this is provided by the assumption. We know that the 2 kilogram object will fall faster than the 1 kilogram object based off of our assumption, right? So what will happen? This 2 kilogram object will be falling faster. Well, eventually we can imagine that given enough time, this 2 kilogram object will find its way on the bottom of the 1 kilogram object since it's falling faster. We can all imagine that, right? So let's rewrite the system, or let's rewrite this diagram to fit that. This system has been falling for a while. The 2 kilogram object is falling faster than the 1 kilogram object. The 2 kilogram object finds itself on the bottom of the 1 kilogram object and is still falling. All right. Okay, so we have our system which is falling. Let's just put this aside for the second though, okay? Let's just put this aside for 1 second. I promise we'll come back to it. But let's think of something else, right? Let's think of what would have just happened if you had dropped just the 2 kilogram object, not attached to anything. We'll draw it over here. We have our heavy object, not attached to anything, our 2 kilogram object. It's over here. We can imagine two scenarios. I'll draw a line. We have our two scenarios, and we can compare the two scenarios, and we'll see what will happen. Let's draw a force diagram, my favorite. So, of course, we have the force of gravity acting on both of these 2 kilogram objects, and they're the same for both because this is the same universe and whatnot, and all that. But let's take another look at this system, right? You'll notice that this system has been falling for quite a long time. The string between the two objects is actually being pulled taut. And if the string is being pulled taut, well, that would suggest that there's a force pulling upwards on the 2 kilogram object, right? the string is sort of being pulled, and the 2 kilogram object is sort of being pulled up. So we can imagine a force acting upwards on this 2 kilogram object. Wait a minute. This whole system that we have over here is 3 kilograms. We would expect this system to fall faster than this 2 kilogram object, right? Since this 3 kilogram system is heavier than this 2 kilogram object. And that's what we've established, right? That heavier things fall faster than lighter things. So this 3 kilogram system should fall faster than this 2 kilogram object. Isn't that correct? But if we look at it, this 2 kilogram object and this 2 kilogram object, they both have the force of gravity acting on them, both the same. But this 2 kilogram object has a force going upwards. That is the rope being pulled taut, the 1 kilogram object pulling the 2 kilogram object upwards. So that would mean that this system is actually accelerating slower than this 2 kilogram object. Do you see why that is? Because these two objects are being pulled they're falling at the same time if they're being pulled taut. But this 2 kilogram object is being pulled upward by the 1 kilogram object, which is being pulled slower. But that's a contradiction. We'd expect the 3 kilogram object, or the 3 kilogram system, to be falling faster than the 2 kilogram system. Have I made my point yet? I could go on and on and on. Do you see how this is a contradiction? By adding more mass, we have actually made this 2 kilogram object fall slower in a way, you know. And of course, we can imagine that the reverse is true. Let's imagine a world where lighter things fall faster than heavier things. Why don't we? So we'll put that in our assumption up here, that lighter things actually fall faster than heavier things. Well, this is all wrong down here. Let's just erase this. If lighter things fall faster than heavier things, and we've done the same thing, we've taken the system with this 1 kilogram object attached to this 2 kilogram object, and we've dropped them both from a tower, actually the reverse would happen, where the 1 kilogram object would find itself on the bottom of the 2 kilogram object. Can we all agree on that? Based off of this assumption. All right. So the 2 kilogram object finds itself on top of the 1 kilogram object. Well, let's imagine another scenario where we have just dropped the 2 kilogram object once again. And once again, we are going to compare the 2 kilogram objects to each other, and we're going to prove that there's a contradiction. Are you ready? So look at both the 2 kilogram objects. Well, the force of gravity is acting on both of them. The same. Force of gravity is the same on both the 2 kilogram objects. But look at the system. The string is still here. It's being pulled taut. But look at the 2 kilogram object. The string is pulling it downwards. There's a force. The force of the string is pulling the 2 kilogram object downwards. So there's force in this direction. This force of the string pulling this 2 kilogram object downwards is not here on the 2 kilogram object. So this 2 kilogram object is falling faster than this 2 kilogram object. And in fact, both of these objects are falling faster than the 2 kilogram object because they're both falling at the same speed. At this point, if the rope is taut, right? But how does that make any sense? This 3 kilogram object, or this 3 kilogram system, I should say, is falling faster than this 2 kilogram object. That means a heavier thing is falling faster than a lighter thing, which is it's a contradiction of the assumption we've already made, don't you see? What else is there? We have proven that there's a contradiction with the assumption that lighter things fall faster we've proven okay, let me start over. We've proven that there's a contradiction with this assumption, that lighter things fall faster than heavier things. We have also proven that there's a contradiction with the assumption that heavier things fall faster than lighter things. So what else is there? What else is there? Well, that only leaves us with the possible, option that all things fall at the same rate regardless of their mass. And that's how Galileo proved that all things fall at the same rate regardless of their mass. There you go. Hopefully that made sense.